Assalamu alaikum everyone. Uh, Today we will discuss about the chain rule in differentiation. Chain rule is the basic rule in differentiation, and we have two basic rules. One is product rule, another one is chain rule. Product rule is applied if two functions, we have to differentiate two functions, and it is we can write product rule as, suppose we are having two function u and v. dy dx of u and v. We are having two function in product or multiplication. So how to differentiate? Take first function as it is, not the differentiation of second. U as it is, differentiation of v is v dash plus second function as it is, keep second as it is, and take the differentiation of first. So it is the product rule. Product rule in differentiation. Now we will discuss about chain rule in differentiation. Chain rule is applied if function is composite of the two functions. Suppose f is a real valued function. Let f is a real valued function. And it is composite of two functions. Composite means combination of two functions. Two functions, say u and v. Then f can be written as f of x can be written as v of u. So here what is given? F is a real valued function. And suppose it is composite of two functions. Composite means combination of two functions. Then the given function f of x can be written as v of u of x. So if now let's consider t is equal to u of x. We are taking the term t, which is given function of u of x. Okay. Now if du by dt and dt by dx exists. If dt by dx and dv by dt exists, we are differentiating this v with respect to t and t with respect to x, and we have taken t as u of x and v is the function of t. That's why we are differentiating v with respect to t and t with respect to x. Then if this exists here, then d of f of x, differentiation of f can be written as d of f divided by d of x is dv by dt. We can write this one as, first take dt by dx into dv by dx. So if the given function is composite of two function, right here function u and v, then f of x can be written as v of u of x. And so how to find the differentiation of the given function f of x is, consider the function u as t is equal to u of x. Now we have to differentiate t with respect to x. Then we got some values and differentiate v with respect to dt with respect to t. Then we will get the differentiation of the given function. Now further consider it can be extended. It can be extended. In the first case, we have taken f is composite of two functions. Suppose if f is composite of three functions, so f is a real valued function which is composite of, means composition of the three function which we are taking as, then f is, we are taking three function u, v and w. Then f is written as f is equal to w of v of u. Okay. Now consider let u equal to, sorry, t equal to u of x. We are taking here similarly t is equal to u of x and v is equal to v of t equal to s. v of t equal to s, or we can take s as u of t. Then df by dt, sorry, df by dx means differentiation of f with respect to x. We will get dw by ds, ds by dt into dt by dx. So what we have to find? Lastly, dw by dx. We will get this ds get cancelled, dt get cancelled, dw by dt, dw by dx is the remainder. Here also this dt and dt get cancelled, dv by dx is the last term, which is the differentiation of given function f of x. Okay, you will be understand while solving problem. So just remember, here we have to take two functions u, v and u, and further we have to take u as t. Here also we have to take, for if this composite of three functions w, u and v, we have to take u as t and v as s is equal to u of t. As t is a function of u of x and s is a function of u of t. Then we have to further find, then we will get the answer. Here write one sentence: if dw by ds, ds by dt and dt by dx exist. If they exist, the value of these exists, then we can take the differentiation of given function of dw by ds, ds by dt dot dt by dx. Then we will get the final answer. So while solving for a problem, you will understand. So I will show you some example based on this formula. So this one is known as chain rule. This rule is known as the chain rule, because we are taking the product of two differentiation function, two functions differentiation. Here we are taking product of three function differentiation of three function. That's why it is known as chain rule. Now let's solve some example. Then you will be understand how to use chain rule for finding the differentiation of a composite function. Now write down examples. Find the derivative of the following function. Find the derivative of the following function, and the function is given to you as following function given by given by is given to you as f of x equal to sine of x square. So f of x is given to you as sine of x square. That means we are having one function is sine, which is trigonometric function. Another one is x square, algebraic function. So this means the given function f of x is the composite of two different functions. One is trigonometric function, another one is algebraic function. So how to find and differentiate this? See, right, the given function is composite of two function composite of two function. Now, so we can write, so f is equal to v of u of x. So what is we are taking? Let u of x equal to x square. Okay. Now let t equal to u of x equal to x square. Similarly, v is equal to v of t. Okay, v of t equal to sine of u of x. We are taking u of x as x square. Further, we are taking u of x as t. Okay, and v of t we are taking v of t sine, and we have taken x square as t. That's why we have to take v as sine of t. Now differentiating these two, t and v with respect to x. T with respect to x, dt by dx is differentiation of x square is 2x by using x raised to n formula. So here differentiation of v with respect to t, because we are taking the function in terms of t. That's why we have to differentiate the v with respect to t. Sin t differentiation is cos t. Okay. Now finally write df by dx. Differentiation of the given function is dt by using chain rule. Write one sentence here. By using chain rule. Differentiation of x with respect to x is dt by dx into dv by dt. dv by dt. So we have dt by dx value 2x into dv by dt is cos t. So what is the t value? T we are taking, right, cos of t is x square. So finally df by dt dx is 2x into cos of x square. This is the given the differentiation of given function f of x. Okay. Directly we can solve it. This is by using chain rule. Directly we can solve. How? Here directly f of x is sine of x square is given to you. So df by dx is, first what is differentiation of sine? Differentiation of sine is cos of x square. Okay, this one is sine of x suppose. So cos x is the differentiation. Now take the angle of sine is x square. X square differentiation is 2x. So directly we will get 2x into cos of x square is the differentiation of given function f of x. By using chain rule, we have to take u and v, two functions. Okay. So this is the first example. Now take another example. It is very simple, but just we have to take the given function in terms of two function, composite of two function u and v. Now take another example. Find the derivative of the following function, and the function is given to you as f of x is tan of 2x plus 3. The function is given to you as tan of 2x plus 3. Right solution. Given function is composite of composite of two function. So we can write f as f of x equal to tan is trigonometry, 2x plus 3 is algebraic term with the constant 2 and 3. So we are taking f as the composition of two function, or we can take combination of two. So composite means tan is different and 2x plus 1 is another function. So v of u of x. Okay. So suppose v of u of x, we can write in this way also. So v u of x, we are taking 2x plus 3. First write the given function tan of 2x plus 3. Okay, so now we are taking it as v of u of x. We are taking this function composite of two functions. Now writing, this can be written as v of u of x is v of u of x. V means we are applying v to u of x. So we are taking u of x as, let right here, let u is equal to u of x equal to 2x plus 3. Okay, and v of t equal to tan of t, and this one is t. So that's why write u of x as 2x plus 3. So we are taking v as tan of t. T we are taking as 2x plus 3, which is nothing but the given function f of x. That means if we are taking f of x as the composition of two functions, then if we solve, then we will get the given function. Okay, now differentiate this. Let u of x equal to, let t equal to u of x equal to 2x plus 3. Okay, and v of t equal to tan of t. Differentiate this with respect to t with respect to x. We get dt by dx equal to 2x plus 3. Differentiation is 3 is constant, so the differentiation of 3 is 0. 2x differentiation is only 2. Okay, because differentiation of x is 1. So dv by dt, here we have to differentiate with respect to t. Differentiation of tan t is sec square of t. Okay, now further, this implies df by dx equal to dt by dx into dv by dt. This is equal to dt by dx, we got 2, into dv by dt is sec square of t. So 2 into sec square of t is, t we are taking as 2x plus 3. Okay, so sec square of 2x plus 3. So this is df by dx. So the differentiation of the given function is 2 into sec square 2x plus 3. So with this I will stop. I will continue in the next class. Thank you. Goodbye. So if you are having any doubt in today's class, you can ask me. And if you have any doubt, you can send me a message. Okay. Thank you.